In this video, we will look at some color concepts that will be helpful as we design. So first of all, we have to have a certain common language to discuss color. And it's not very easy. For example, when we define space, we have length, width, and height. And that information gives us some idea of what that space contains. We have a similar way to describe color: hue, value, and chroma. And this is the order in which you want to define color. So what is hue? Hue is the name of the color. When you look at a color, is it a red? Is it a blue? Is it a green? What basically is it? Then the value is whether it is light or dark. If it's got low value, it's a darkish color. If it's a high value, it's very light. And the value scale are grays. If you squint your eyes just a little bit, you can see the grayscale a lot better in a color. The hue becomes less pronounced. Finally, chroma. Chroma is saturation. How strong is the color? A strong color is bright and intense, and a weak color is kind of dull and grayish. Gray is one of those colors that possess neither chroma nor hue. It is only value. These two concepts can be put together and create a virtual globe where the axis of the globe goes from light to dark. That's the value scale. And then around the equator, the colors go from weak to strong, and that is the chroma scale. When laying it out as a sphere, you can then make some color observations. Slicing through this sphere vertically, we can see the range of values in chroma for one specific hue. Slicing through the sphere horizontally shows the chroma of all the hues at a specific value. Munsell made charts to categorize color. He would start with a color and then add a little bit of gray, a little bit of gray, a little bit of gray, until he finally got to the middle grayscale that you couldn't see the hue very much. When he laid out this chart, it was like a grid where you could actually call out a certain color based on the hue, the value, and the chroma. This example would be labeled a B48. So we would know it's a blue, a value of 4, and a chroma of 8. As Munsell worked on these colors, he realized that different hues have their strongest chroma attained at different values. You can see this at this example, that one color has the most range at the top end of the scale, and the other color has the most range at the bottom end of the value scale. Putting them all together, we see that this sphere is not really a sphere, but rather oblong-shaped, where some colors extend beyond a shape of a perfect sphere, and others not so. When deciding on color in a space, we need to consider color balance. Color balance is where all the colors in a space work together without one being more pronounced. In this example, red and green balance pretty well. They're equally in each color's in brightness and saturation, pretty good. However, when you get to different color ranges such as blue and orange, which are also opposites, they don't balance quite equally. In other words, that blue really carries a lot more weight than the orange does, and so you need more orange than blue for this balance to work out. And it's even more noticeable in yellow and violet, where just a little bit of violet can balance out a lot of yellow. Should you require colors of equal amounts for a specific project, but you still wish to achieve a color balance, you can adjust the chroma and value. In this example, the value of blue was raised and the chroma lowered a little bit, while the yellow was made lowered also just a little bit in value. And just doing that little tweaking creates a situation where both colors could be of equal amounts in a space and still would be balanced. Hues are displayed in a variety of ways, known as color models. A color model is a set category of colors that can be combined to produce a larger set. Color models use the following hierarchies in ordering their colors. Primary colors are those colors that cannot be reproduced. Secondary colors are those that are created by combining equal parts of two primary colors. And tertiary colors are created by combining equal parts of a secondary and a primary color. Beyond that are complex colors, and they're typically not located on color models. The first one is scientific, the color of light. This is also known as additive, or RGB. So this model describes how the hues in white light interact. So the primary colors for this set is red, blue, and green, with secondary hues of yellow, magenta, and cyan. That if you put all these colors together, you get white light. Our monitors have this. That's why we have R, B, and G settings when we work on graphics on our monitors. Printer's color, however, the color of printed media, subtractive, or CMYK, because the primary colors are magenta, cyan, and yellow. And these colors, then when you print over each other, theoretically make black when you put them together, but in reality, it becomes a muddy brown. And so we usually have black as another color. And that's why when you buy these ink cartridges for your printer, they're CMYK, cyan, magenta, yellow, and K for the black. And that is why sometimes when you see something on a screen and print it, it may not print exactly the same. Because from screen to print, the computer is converting RGB color to CMYK color, and they don't quite line up one-to-one. Some computer programs that you purchase take that into account and have settings so that the colors match much better. Colorant is the color of paint, and it's used in paints, and those colors are red, blue, and yellow. And the secondary colors are orange, green, and violet. Again, if you mix all these colors together, you theoretically get black, but that's not really the case. So you also need white and black. Now, as for the colorant wheel, there's still two different versions of that. One of them is a perceptual, and one of this is a conceptual. Perceptual is how you see the colors. Perhaps you, as a kid, played a game where you stared at a red picture for a long time on a page, and then looked away onto the white side of the page, and there was like an after image. Perhaps it was a bluish-green after image. So the opposite of each color in the perceptual model is what would appear after staring and looking away, how you perceive the color. Putting that together, you get this perceptual color wheel that's slightly different than the conceptual one. The conceptual one is what you mix to get the other colors. So for example, the opposite of red, you mix the colors equally apart, which are blue and yellow, to get green. So the opposite of red is green. Whereas the opposite of red in the perceptual is more like a blue-green, because that's what you'd see when you look away. Once you have a certain organizational scheme selected, whether perceptual or conceptual, you can then start making some observations and associations with the colors and how they're going to work together. In both wheels, we have warm and cool colors. However, in the perceptual ones, there's a couple of colors that can go either way depending on what's adjacent to them. You can see the warm colors are obviously, the reds and the yellows and oranges and kind of a yellowish green. But then we come up to these greens or this red-violet kind of color that really could fall one way or the other depending if the colors adjacent are cool or warm. Again, perceptual deals more with how it's perceived. The conceptual are pretty clear. The warm colors tend to be in the reds, the yellows range, and the cool colors in the blues and the greens range. It's pretty standard. Instead of bouncing back and forth between perceptual and conceptual, let's stick with the conceptual model for the rest of these color observations. It is important to categorize colors as warm or cool because of the way we perceive them. Cool colors tend to receive, and warm colors tend to advance. These two images, taken from a color magazine, show a room, and they are both sized the same size and scaled the same scale factor, and cropped to about the same view. The warm color scheme seems to be a smaller room than the cool color scheme. Here's another example of a space. Again, the red colored room seems closer to the camera than the green colored space. Yet it is the same space. It is amazing how much adjacent color can affect our perception. In this example, from the archimedeslab.org, these almond-shaped lozenges are all the same color. The reason they look so different is because of the adjacent color. When putting a band of color through them to negate the adjacent color effect, it is obvious that the lozenges are all the same color. Lighting in a room also plays an effect. This blue wall is the same color, but whether it's regular sunlight in the space, incandescent light in the room, the flash photography, the color of light changes how you perceive the space. Adjacent color can affect how we see warm or cool colors as well. In this example, one side of the lizard was colored in a magenta color, a cool color, and the other side a red color. But because of the background, it all seems equal. This analogy could be similar to how on a 50-degree day in July we might feel cool, and a 50-degree day in January, we might feel warm. Here are two other color examples. In the top group, the band of orange is the same all the way across, and yet with the yellow background, the orange looks dark, but with the red background, the orange looks lighter. Similarly, the gray band down below is one color, but because one side is kind of bluish, the gray looks kind of yellow, and the other side being a yellowish background makes the gray look bluish. Let's turn back to the colorant color wheel to review our terminology. Primary colors are those colors that cannot be reproduced by mixing. In our colorant color wheel, that's red, blue, and yellow. Secondary colors are made by equal parts of primary colors. So equal part of red and equal part of yellow will create a secondary orange. Equal part of yellow and blue, green, and blue and red, violet. And tertiary colors are created by mixing equal parts of a secondary and a primary. And the name of the color is where they came from. So example, red-orange came from mixing red and orange. Blue-green from blue and green. Beyond that are considered complex colors, and they're typically not shown on a wheel. Almost all colors can be traced back to those 12 colors on the wheel. And so the first thing you need to look at when you look at a color, you ask yourself, well, what color family? What's the hue? And then after you see the hue, verify the value and the chroma. So these three are all in the yellow-green family. They're all yellow-green colors. And then once we know where they are in the color wheel, we can make some color associations. And remember that adjacent colors affect how we perceive a color. Let's look at some basic schemes. One of the simpler schemes is a hue with a neutral. And in these schemes, grays or color may dominate. It depends. This is an example of one such scheme. Usually you use a hue and a neutral in place where colors is not as important piece. For example, a site plan, perhaps a wall section, something of that nature, where you don't need to have specific colors shown, but you want to show some differentiation of the different parts. Monochromatic is also a very common scheme in that we take one color and then work with the values of that color. And it's usually very restful. Monochromatic is a very restful type of scheme. To get interest, though, that restful schemes needs to have contrast in value or chroma or variation. In this example, one side goes from light to dark, then one goes from dark to light. The interplay between the two makes it interesting. Here's another example of a monochromatic scheme. Very restful, and the colors work well together. Analogous schemes are colors side by side on the wheel. It works the best when they are definitely warm or definitely cool. The interest in it depends on the variation of intensity or value. Analogous schemes also tend to be very common and popular to do. Here's an example of an analogous scheme. We have yellow, orange, and red, and then grays in the background so the building stands out. Here's an interesting image showing the analogous idea with progression as well. So the building at this end is green. The building at this end tends to be this purpley red, and the progression goes across that streetscape. It could be a very interesting streetscape. This building works well with this one because they are analogous. This one works with this one because they are analogous, and so forth. So each building side by side becomes analogous. And this progression was put together looking at the Munsell color sphere, applying certain colors to certain parts of the building, making an interesting streetscape. A couple of analogous schemes here. We also have ceilings and floors that come into play. They are surfaces that have color and can affect the room. Here's a blue, violet, and violet scheme. Yellow, orange, and orange scheme. Complementary. These colors tend to be dramatic and vigorous. When using complementary colors, take care not to use strong chroma because that can create a very strong effect. In this one, that green and that red really are fighting for your attention. On the right example, they were both toned down. The chroma has been toned down, and some of the value was moderated so that these pairs of colors work better together. This example shows a couple of successful complementary schemes. Notice how the violet in the left example is lightened up quite a bit. This is showing color balancing that we discussed earlier. By lightening the violet, it doesn't overwhelm the yellow. In the right example, the chroma of the blue has been toned down so much it's almost a gray. If the chroma of the blue was as strong as the orange, the room would have been overwhelming. Split complementary is another way of having some sort of tension between the colors, some sort of dynamics between the colors, but instead of being directly across and straight across, which will give us the most dynamic element, we go to the sides, and that kind of gives us some interest without having that jarring sensation. Here's an example of violet, orange, and green. Double complementaries are interesting in that you choose a color and its opposite, but then also it's adjacent. So in this case, the opposite of this color is this one, the yellow, green, and the red, violet. And then this one, the yellow, orange, and the blue, violet, kind of go back, are opposite from each other, but they are adjacent to each other as well. There's kind of a dual mode. It creates a very complex situation, and it could get a little bit too much. So in this scheme here, we see orange, blue, green, and red all together. And you can see right now there's quite a bit of dynamism going on here. There's a lot of things going on. Your eyes are moving a lot throughout it. It's a very active space. On the other side, the bedroom, the same thing too. There's a lot of color, a lot of play, a lot of texture. That also creates a lot of dynamics. Sometimes in this kind of color scheme, it's better if you use a 60-30-10 rule so that the largest area, which tend to be the walls, account for 60% of a room's color. And that's going to be like the biggest color factor, followed by window treatments and upholstery, which is about 30% more, and the accessories 10% more. This is a good way to balance all these out. Finally, a triadic scheme is from hues that are equidistant from each other. And one of the most common triadic schemes is yellow, blue, and red. Here are two examples of triadic schemes. They both use violet, orange, and green, the secondary colors. In both, the chroma of the violet has been weakened to better work with the other colors. In the left scheme, the green has also been lightened so the room has color balance. In the right, however, you can see how the green dominates the room since its chroma is pretty intense. That was the desired effect for this space. The wall was to be a focal point. However, additional elements of black are sprinkled throughout to help balance the room. Finally, what we call many-hued schemes. In this scheme, we want to repeat a pattern or an element so the room does not become too cluttered because the colors are all over the place. Some color schemes are important in historical references. And there are some paint companies, this is an example of the Mautz paint color scheme, where they have researched these colors went together in buildings of this particular time period or this particular style. And so if you use these colors, they will work well and it would match the historical period of the time. This is a product you have probably seen in art supply stores. It is a disc with a pin in the middle that lets the middle portion rotate. On both sides, we can see the color wheel. One side shows color associations, and the other side shows color mixing. There's some places online, this colorschemedesigner.com, although it's made for web design, can certainly work for other things as well. And you can decide what kind of schemes you're looking for, and they'll show you color combinations that could work together. And you can see whether or not you like the effect of the choices you've made. Another color source is color.adobe.com. This one you show the color wheel you're looking for. I click on the circles down here and they'll show you where on the wheel it is. And this also gives you the RGB of the color, which is good. A good suggestion when you work in a space is to paint an area, maybe about 5 feet by 5 feet. Get a little batch, a small batch of color and test an area and see what it looks like. Look at it in direct sunlight. Look at it in indirect sunlight. Look at artificial light and compare that to color chip. Larger areas of color will appear darker than what's on a chip, And colors are affected by those around them as well. A touch of color might be what a space needs. In this particular example, from a book called Home by Design, you can see that one wall is painted blue, and that looks so much better if it was all painted white. So if the whole space was white, it's still the same space, but that one wall being blue gives that one accent, and it really makes the space more interesting. Color doesn't have to be strong either. This example here, where this wall is just a tad darker than the molding in the room. If it was all white, the molding wouldn't pop out. But by having that wall just a tad softer gray, just a tad softer color, all of a sudden it makes the molding in the room, which is a special part of the room, more defined. Another good color tip is to take a cue from nature. The ground is dark, the sky is bright, and maybe our spaces should be that way too when we paint different areas of a room. And this is the example here. Here's where a light color is at the top, medium color, and then a dark color at the bottom. And this looks balanced. In this design, that middle section seems awfully heavy and almost like it's teetering. Which is better, to paint the ceiling white or to keep it this darker natural tone? What you need to consider is, what is the intent? If you want the space to have some openness and some airiness and some brightness, well then painting the ceiling white is the way to go, because it does open up the space. If, however, you want some coziness in that space, maybe you want it to feel comforted and kind of cocooned, well then the darker ceiling is the correct choice, so you feel that you're protected. So different colors can be used in a space, and depending on the intent, it could still be fine. When you start deciding which colors to use, consider the mood you want expressed. Is it warm and cozy, rich and refined? Is it verdant or cool? Then use the information in this presentation to select colors that will work well together and express this design intent.